stretching horizontally if the number is between 0 and 1. So these are the basic transformations. And let's go through some examples that may be like those you have on your assignment. Okay, it gives us a function, f of x equals x minus 4 quantity squared plus 2, which is a transformation of the basic function y equals x squared, the same one we were just working with. Describe the transformation that the function represents. So what they want us to do is look at each change that's happened to the y equals x squared and describe what that would do to our graph. Okay, so first thing I notice is outside of my parentheses, I have a positive 2. Now we learned that that would shift the graph up 2 units because of the plus 2 outside of our parentheses or our function. The other change that has happened is this minus 4. Notice where it's located. It's located inside those parentheses, so it's within the function. Okay, and remember, anything inside of there affects left and right, and it affects the opposite of what we would think. So a minus, normally when we graph, minus takes us to the left, but it actually represents a shift to the right. And it shifts to the right 4 units. Okay, so we've described that's everything that was contained in there. The squared doesn't, that was just part of our original function. Okay, let's try another. Okay, this has some more. It's a transformation of the function y equals x to the 3rd power, which if you're not familiar with it, that graph looks something like this, y equals x to the 3rd. But they've done some transformations here, which would shift it and maybe stretch it and maybe flip it. Okay, so let's take a look at one thing at a time. Well, the first thing that I noticed is it is multiplied by a negative 2 here on the front. We're going to handle the negative and the 2 separately. Notice they are outside of those parentheses, outside of our operation, so they're going to affect the y value, our vertical change. The negative tells me that it reflects over the x-axis, or flips the graph upside down. So if we wanted to know what that would look like, that would change our graph to look like the red instead of the blue. Flips everything upside down, or reflects over the x-axis. The next thing I notice is the 2 multiplied by a 2 in front. That's going to stretch vertically, again because that's outside, by a factor of 2. Okay, what's our next thing that I see? I see this minus 5 here outside of the function, once again outside of the operation, so I know that's up or down. The negative tells me that's going to shift down because it's negative 5. And there is one thing left that we haven't addressed, and that's the plus 1. Notice that's inside the parentheses, so that affects our x values, or our left and our right. Plus means that it's going to shift it to the left. And it's going to shift it left 1. Okay, so remember, anything inside those parentheses is opposite of what you would naturally believe. Okay, so those are all the 4 different things that are going to happen to that graph. We demonstrated just the reflection is always demonstrated in the picture. All right, here's another. This is a transformation of the function y equals the absolute value of x, which basic function looks like this, basically. Okay, that's y equals absolute value of x. This over here on the left, the f of x equals 1/2 the absolute value of x minus 1 plus 2, has made some transformations to that graph. So let's talk about what would happen. First of all, I see a positive 1/2 in front. Notice it's outside of the absolute value, so it's affecting the y values, or it's doing vertically. It's less than 1, which means it's going to shrink the graph vertically by a factor of 1/2. What you would do on your points is multiply all of your y values by 1/2. The next thing I notice is on the end here, I have a plus 2, also outside of the absolute value, so I know that affects vertical change. It's plus 2, so that would move the graph up 2. I guess I should say, I'm going to shift it up 2. And there is one more thing happening there. There's a minus 1 inside the absolute value, so that affects our movement right and left. Minus is going to move it to the right. And there we have it. Okay, here is one last example. It's y equals the square root of x, which is basic function. The basic graph of the square root of x looks like this. Okay, but we've made some transformations, so let's talk about each of those. Again, I notice I have a positive 3 in front. It's outside of the square root, so I know it affects the y values or the vertical chains. So this is going to stretch it because 3 is bigger than 1. Anytime it's greater than 1, it's a stretch vertically by a factor of 3. So all the y values are going to be 3 times higher. The next thing I notice is the plus 1 on the end. Again, it's outside of the square root, so I know that is vertical change. It's plus, so that means it's going to move it up. It shifts up 1. And the final thing I notice is the negative inside the root. Okay, and what that's going to do is, since it's inside the square root, it's going to reflect over the y-axis. Or, as we could say, flip it sideways. So instead of going to the right, it would go to the left. Our actual final graph, we'll go ahead and do this one, would be up 1. So it would start here and be 3 times as steep. So it would be something like that black graph right there. The original looks like this red one over here. And then we reflected over the y-axis, moved it up 1, and stretched it vertically by a factor of 3. That's just a very basic sketch of what it might look like. Okay, so these are the different transformations that can be done to a function and where they're located in the function.
Nothing that you tell me. Take a picture. No, record it.
Okay, so we've talked about different transformations that can happen.